So chapter 2 in class 9 syllabus is polynomials. Now, first of all, we should know what are polynomials, how to identify polynomials. This is very important. What are polynomials? So polynomials are basically algebraic expressions, right? They are algebraic expressions. But what type of expressions? They are algebraic expression in which the power of the variable, not the constant, right? Power of the variable. Variable means your x, y, and all these values. Power of the variable is a whole number. Whole number means it cannot be negative. It can be 0 or any positive value 1 to infinity. So algebraic expressions, what are polynomials? They are algebraic expressions in which the power of the variable is a whole number. For example, if I have x square plus 5, this is a polynomial. Why? Because the power of the variable is a positive. So x to the power 2, this is positive. So if I have x to the power minus 2 plus 5, this is not a polynomial because here the power of x is negative. So these are not polynomials, right? So suppose I am having x plus 5 to the power minus 1. Some people say that this is not polynomial. That is wrong. This is a polynomial because we don't have to see the power of the constant. We have to see the power of the variable. Power of x here is nothing means 1. Nothing is written means it's not 0. It means 1. So this is a whole number. So whenever the power of the variable is a whole number, then we can say it's a polynomial. So if I'm having x to the power 1 by 2 plus 7x plus 3, this is again not a polynomial because power of the variable cannot be a fraction. Power of the variable has to be a whole number, right? So this is very important. Sometimes you get like this. Is this a polynomial? Again, no, because when I solve this, I'm going to get 7x to the power minus 1. X will come up, you'll get x to the power minus 1, not a polynomial. So the first thing is to identify what are polynomials. So this definition you should keep in mind that the power of the variable is a whole number, right? Now, what are the different types of polynomials depending on the degree? Now, what is the degree of a polynomial? Degree is the highest power. Degree is the highest power. That means if the highest power degree is 2, that is called quadratic polynomial. And when degree is 3, that is called a cubic polynomial, right? So constant example I can give of a constant polynomial is 7. So any number like this without a variable can be written as 7x to the power 0. So degree is 0 here. So 7x plus 5, this is a linear polynomial because power of x is 1. X square plus 3x is quadratic because the highest power here is 2. X cube plus 7x square plus 8, this is a cubic polynomial because the highest power of x is 3. Okay, so degree 0, 1, 2, 3. This is classification of polynomials on the basis of the degree. Now we can also classify polynomials on the basis of the number of terms. We can also classify polynomials on the number of terms. So if you have one term, that is called a monomial. If there are two terms, it is called a binomial. If there are three terms, that is called a trinomial, right? So monomial is one term, only one term, x. Binomial, two terms, x plus y. Trinomial, three terms, 7x square plus x plus 5. These are monomial, binomial, trinomial, right? So all this comes under polynomials depending on the number of terms. The number 0, okay? So the number 0 is called a constant polynomial. The number 0 is called a constant polynomial, but it is also referred to as a zero polynomial. In specification, we say that zero polynomial, right? So there are many types of constant polynomials. 1, 2, 3, 4, 5, all these are constant polynomials. But when I'm talking about the number 0, we refer it to as a zero polynomial, right? All the others are constant polynomials. So if you are asked what is 0, the number 0 is the zero polynomial, right? And if you are asked what is a constant polynomial, 1, 2, 3, 4, all these are constant polynomials. All these are constant polynomials. So 0 is a zero polynomial and 1, 2, 3, 4, 5 is a constant polynomial. So zero polynomial, there is only one example, that is 0 itself. constant polynomial, there are 1 to infinity, infinite number of answers. Right. So once we understand what is zero polynomial and constant polynomial, monomial, binomial, trinomial, then we have done linear, quadratic, and cubic. Then we have to know what is the meaning of coefficient. So if you look at this word coefficient, coefficient is the number written along with the variable. So suppose they ask you, what is the coefficient of x cube? The coefficient of x cube. So there is no number here. That means it is -1. What is the coefficient of x square? Coefficient of x square is 4. Coefficient of x is 7, right? So this is the meaning of coefficient, right? So here, as I told you, these are example of constant polynomials, and the constant polynomial 0 is called a zero polynomial. So 0 is a constant polynomial, but it specifically is called a zero polynomial, right? Now, going further, very important statement that has to be done here is about this we have already done, monomial, binomial. The degree of a non-zero constant polynomial is 0. What is the degree of a constant polynomial? So suppose I am taking a non-zero constant polynomial. 0, I told you, is a constant polynomial, also in particular 0 polynomial. But if you take any non-zero, 7, 6, 8, the degree of this is going to be 0. The reason is that 7 can be written as 7x to the power 0, 6 can be written as 6x to the power 0, 8 can be written as 8, 6 to the power 0, and so on. Right? Find the degree of the following. Degree is the highest power. So here it is 5. In this I find it is 8. So degree will be the highest power of the polynomial. So you just have to go to the polynomial and see which is the highest degree. Next, zero polynomial. This we have gone through. Now we are going to do the exercise. So which of the following expressions are polynomial in one variable? So the first thing I told in today's video is how to identify polynomials. So this is a polynomial because the power of the variable is a whole number. So power is 2, power is 1. So this is a polynomial. This is a polynomial because y square, the power is a whole number. 3 root t plus t root 2. This is not a polynomial because when I say root of a number, the power is 1 to the power 2. So if I am saying root x, the power is 1 upon 2. Okay. So root t means t to the power 1 by 2. So this is not a polynomial, right? So 3 root 2, 3 there is no problem. We don't have to see anything here. But when I look at the t, that is the variable, the power is 1 by 2. And therefore, this is not a polynomial. Okay. So this is not a polynomial because the power of the variable has to be a whole number. Again, this is not a polynomial because y plus this y is down. When I bring it on top, this will become 2y to the power -1. And again, -1 is not a whole number. If you look at the last one, all the powers of the variable are positive numbers. They are whole numbers. But the question is it a polynomial in one variable? So this is a polynomial definitely, but it is not a polynomial in one variable. It is not a polynomial in one variable. It's a polynomial in 1, 2, 3 variables, right? So this is how we identify whether algebraic expressions are polynomials or not. Write the coefficient of x square. So coefficient, I told you the number with x square. What is the coefficient here? Here, the coefficient of x square, no number is written, so that is 1. So coefficient of x square is 1. Okay, so they will not write here 1. It's understood that there is 1. So coefficient of x square is 1 here. Here the coefficient of x square is -1. There is a negative here, so -1. Here the coefficient of x square is pi by 2. And here there is no x square. So no x square means this question can be rewritten like this. And coefficient of x square is what now? 0. So first answer is 1, second answer -1, third answer pi by 2. And the fourth answer is 0. Then the next question, give an example of a binomial of degree 35. Now, binomial, I told you 2 terms. And degree 35 means the highest power is 35. So you need to give examples where the highest power is 35 and there should be 2 terms. So this is an example of a binomial with degree 35. Okay. So we can have anything like this. So the power of x, the highest power of x should be 35. That makes it a degree 35. And binomial means there has to be 2 terms. So all these are examples. Monomial of degree 100. Monomial means 1 term and degree should be 100. So x to the power 100, right? There can be 1. Polynomial means only 1 term. So 1 term with degree 100. So you can have any polynomial like this where the power of x is 100, but there should be only 1 term. So question number 1, 2, 3 completed. Now we go to question number 4. Easy questions. Write down the degree. So this will come in 1 mark questions only, all MCQ type. Write the degree of this. Degree I told you is the highest power. So here the highest power is 3. Here the highest power of the variable. Okay, just check the variable. Higher power is 2. Here the power of t is 1. And here there is no variable. So this can be written as 3x to the power 0. It's a constant polynomial. A constant polynomial has a degree of 0. So here the degree is 0. So degree here is 3, degree here is 2, degree 1, and this is degree 0. Classify as linear, quadratic, and cubic. This also we explained in the beginning of the video that we saw what are linear. Linear, the highest power, that is the degree is 1. Quadratic means the degree is 2. And cubic means degree 3. So here, what is the degree here? The highest power is 2. So this is going to be a quadratic. X minus x cube, the higher power is 3. So cubic. Here the higher power is 2. So this is going to be quadratic. Here the highest power is 1. So this is linear. Higher power is 1. So linear. Okay. Power of t is 1 here. This is r square. This is quadratic. Power is 2. And the last one, 7x cube, power is 3. So it is cubic. So the introduction of the chapter deals with classification of polynomials on the basis of linear, quadratic, cubic, and monomial, binomial, trinomial, finding coefficients, and of course, identifying polynomials. Now in the next video, we'll be doing the second exercise.